Hey guys, so I'm Skytrias and I'm working on an open source clone called Everpuzzle, and it's a clone based on Tetris Attack and Pokémon Puzzle. Some games that weren't really aren't really released anymore, and the concept of it is just fallen away. And some people still really love this game, so maybe you like it too, or maybe you're just interested in the game or how it maybe works. And yeah, today I just really want to show you how this works and how what I'm using and why I'm using it, why I decided for Rust, and what the game sort of looks like under the hood. It's not done yet. You can still contribute. That's just what I want to say. So yeah, I'm Skytrias. I have worked on a few clones similar to this. One called Swap and Pop. It was programmed in TypeScript with Electron. I don't really like Electron, so that's that. TypeScript is also, it sort of worked only 50% of the time. It really had a lot of issues, and it wasn't really worth it to switch from JavaScript to that. We also never really used it, and it wasn't working, like I said. Relative paths and such, just, it was a pain. So why waste your time on tooling if you can make the game better, So then I worked on another clone with the Godot game engine that was programmed in GDScript. And I've started to hit points where it just was too messy, and I don't know, I didn't like the way some of the scripting went, and I started to see some problems with object orientation. Really, it was just too messy at some point. I couldn't really extend, or I couldn't really put a lot of code into other scripts and such, because it just would have ended in even more mess. That's at least my opinion. So both were almost finished, but it was always missing some steps, and when it got hard, we just sort of left. So some problems, like I said, TypeScript, it never really worked fine for us, at least, and now Rust is just so much better. And GDScript, like I said, I think Python is cool, or the Python-like scripting is cool. But GDScript has some problems, and it's also supposed to be really slow. So you could switch to C++, but what's the sense? GDScript is there. It's much easier to use. And yeah, that was a problem, for me at least. So, like I said, slow. Electron and such, they're not used to known for being fast, and also had some limitations with Godot. Godot was pretty easy to use. I love that about it, but some shader stuff, I've hit some limitations on that with post-processing. Not something I was really going to use in the game anyway, but I've just had my problems, and also some code logic wasn't really working. References to other entities, objects, weren't really working when I destroyed them, and it was really messy. So another problem was no multi-threading. So why make a game that isn't multi-threaded, or that you really don't have a chance of making multi-threaded? I think that's a problem with some game engines or frameworks that make your life easier, but maybe you cannot go so much under the hood and multi-thread perfectly fine, or they just don't really help you at that. So goals with Rust, like I said, safe coding. This is what TypeScript tried to do, but it never really worked for us, at least. And I feel like Rust does this 100%. I'm fine with it. It does everything I want, and even better than any other language I've used so far. Heck, it even showed me that my U32 cannot go, it can never be minus, so my comparison if it goes below 0, never worked. So I would debug this and I would see, okay, damn, the type was just wrong. But no, Rust told me this. So just one use case. So also multi-threading game logic. So obviously Rust tries to be safe and allow for multi-threading, and this is definitely possible. So also something I've seen with Rust is the compile size. It's really small, and I love that. I don't want to have bloated files or bloated executables when I can have 1 megabyte, small games. Why would I do that? So with UPX, which is a executable compressor, you can make the file even under 1 megabyte, which is just amazing, in my opinion. So yeah, so a release build, by the way. So Rust, obviously I don't want to make my own game engine or game framework. I'm not that crazy. I just want to make a game, make a project for more people, and that's why I'm going to use the Amethyst game engine. It's using Specs, which is a parallel ECS, and it's just really cool because it's doing the work for you, or it pretty much allows you to parallelize your code simply by saying, okay, like Rayon, you can just say, okay, this for each loop should now just be parallel. And then obviously it's not going to be that easy, but it's supposed to be. We'll see. I mean, I hope that it's going to be possible for us to multi-thread all the game logic. But with Amethyst, it's definitely possible. So also Amethyst is data-driven, so it doesn't need to recompile, which is very nice for us. Because Rust takes a bit of time to compile, it's sometimes good to not have to recompile. For Amethyst and my code now, it takes about 8 seconds or 9 seconds on my PC. It's probably going to take longer or not as much time on your PC. But still, it's a lot of time to compile, and the problem with game development, it's really test focused. Like, you rerun the game all the time and you see if it works or not. But this is actually something I've seen in or at least with VS Code, which has type checking all the time, is that I don't even need to recompile the game so much. It's just when maybe some references get wrong, or some files aren't there or where they should be, and that at runtime it cannot find these. So that's the only issue where the game really crashes, or yeah. And all the other stuff is just handled by Rust when writing code. We can see all the problems. So that's why I use VS Code, by the way. I've been using Vim, but like I said, the seeing all the issues and such in your code while writing it is really helpful. So as well as that, Amethyst has an active community, which is just amazing. If I have any question, I can just go there and ask, and they mostly help me. Mostly. If they know any better, obviously. Which most of the time, if you ask anything about Amethyst, you'll get everything back you need to know. So one of the things that I really liked about Amethyst is the good thing that they actually try to be, they strive for performance. That's not something I've seen the other game frameworks do in Rust. So, applause for Amethyst for trying that and actually also doing that. They're using the parallel ECS and such, and you cannot parallelize everything in game development. That's the issue. But things like physics and game logic can definitely be parallelized. So, yeah. Like I said, the project, I've already started working on it. I'm around 50 commits, 1 commit a day or more. So, the basic game logic has also already been implemented. Let me quickly show you that. So if we do a cargo run, you can see the game working. Obviously, if you don't know about the game yet, I'm going to show you that in just a moment. But yeah, you see it's already working pretty fine. And here's a little video of that I'm just going to try to explain a little bit. So you pretty much just have a grid of blocks that that exists in the game, and then you try to beat your opponent by matching them. So if you have 3 of the same color, they'll match and they'll go to your enemy, and these blocks that you cannot destroy or that you can destroy by matching them will go away. So here is match, and the enemy blocks will go away. And it's really cool. It's really competitive, and it's also a fast-paced game. That's what I love. And I just really love to make this game exist in our case, or with Rust, with optimization, and have test code and such. Have everything be there, and just work like the old games. So this game looks very simple, but it's actually pretty difficult to play or to remake. There's a lot of things going on, a lot of logic, and if you like that sort of thing, that sort of programming, I'd say this is a project for you, because it gets heavy. So, like I said, I've got the basics down, so everything here you see should be working. The cursor is working, the blocks are working, they can fall down, they can match. Now what I need to do is the interconnectivity of both, maybe make even 4 players working, that sort of thing, laying them out, making the angry blocks there working that you can delete, or that get spawned, and making the whole system here also working. So they gonna rise up, so if you are playing slow, you will lose at some point, or that you can make a difficulty and such, all these sort of things. So it's pretty hard. It's not as easy. So what I also want to focus on, with this release, is the test code, or with this project, I mean. Test code is pretty important with this game. It has a lot of logic, and that logic should stay put. And if we change anything in the game, it should be notified, or we should be notified that test code doesn't work anymore. So if you don't know what test code is, it's pretty much everything your logic, all of your logic can be tested. You can write test code for that, see if it returns the same thing that you expect. And if it does, that's good. If it doesn't, you will see that you broke something somewhere in that function. So yeah, I also strive to be the best clone possible. So yeah, I'll need some help for that though. See, that's the thing. It's open source. You can help if you're interested. Obviously, it's hard to get into Rust, into Amethyst, which is a different game engine, into ECS. That was my biggest problem. It's really hard, but I can help you with that. If you're really interested in working on this project, I'll help you. I'll help you learn how to code, whatever. No, you should know how to code, but I'll help you with ECS and such, and how I work on the game. So yeah, I also want to extend the old game. So add new features, maybe make the game more interesting. That's all gonna come and be optional for the players that want to just play the old game. But I also want to see where this game can still go, and what some suggestions maybe are, and from other players who are just interested in, or I maybe don't have the best idea of what can make this game even better, so maybe others have. So I'm gonna talk how the clone works later. If you're interested in contributing to this project, then watch the later part. Now I'm just gonna say how to contribute in general. You can try the game out on the releases page on GitHub. I'll just show it here. Here on Skytrias Everpuzzle on GitHub, you can see, you know, some of the goals again, some things I've written down. Whoops. How to build the game if you want to work on the code, how to play. You know, you can move on some instructions that aren't in the game yet. How you can contact me on Discord and such. And also some data, some links that are really important, or some of the Tetris Attack Discord channel where you can also write with some of the people who are more experienced. So here are the people who are actually making tournaments and such. So they really know the game in and out. So it's important, you know. So that's about it. Here's the releases. You can download the zip file, and you know, it has the executable file. You just need to extract the whole folder and then into a new folder, and then just run the exe file. So I'm just going to show you this. So if you have Everpuzzle Windows, so this is what it's gonna be looking like. You can just run Everpuzzle, and you need the source folder here, otherwise it's not gonna work. It contains the sprites for the game, and it also contains the data files that you can adjust yourself. This is pretty cool. So in my editor, I could just push in this file, and you can see, okay, the title. You can change everything yourself, pretty much, or vsync, that sort of thing. Or the way some of the inputs are recognized. So moving up is up, down, left, blah blah blah. So it's configurable. That's pretty cool, right? That's what Amethyst does for you. It's data driven. So here are also the release notes if you're interested in some of the code and, you know, some of the approaches I take. But yeah, if you don't know how to use GitHub, you know, there are a lot of videos on this. So you can file issues and bugs and suggestions and everything. So if you're not really a coder and you just want to help the game grow, here's where you get started. Pretty much you can go on this issues tab and you can make a new issue, and you can write whatever you want. You know, describe it well, and maybe put a suggestion on here. For example, here I have a ROM file that contains all important game data, so users can customize for fun. And then I'm writing some things that maybe need to be done, and I can put a label on this, and yeah, that's pretty much it. And then other people can discuss this. So also, if you were wanting to contribute code to this project, you can start here. This is a good first issue, for example. You know, it's linking to code in a file which is gone by now. But it's pretty much telling you, okay, here's where you can get started. If you're new to this, or help wanted, where I had some problems and such, you know, adding control support, it's been problematic. Yeah, if you're interested, you can get started here, or you can contact me on Discord. I'd recommend that pretty much if you want to help me out with code. So also, another thing that you can do is track data. So you can play the old games and just, you know, tell me what feels off, what you think might be wrong, you know, if the game plays worse or things like that in general. So with that pretty much said, that's gonna be it for this presentation. If you're sticking on to this video, you can, I'll just tell a little bit of how the code works underneath, and yeah. So thanks for watching, and stick on if you want. So by the way, maybe make a GitHub, a Discord channel for the whole project if you're interested, or if a lot of people want to contribute now. Look in the description then. So I already pre-recorded some stuff, but I forgot to press record. I hope this is still running. Yeah, it is. Okay, so let's look at this. I already drew a lot of stuff. Like I said, I wasn't recording. So if we run the game again, you'll see that it's a grid-based game, right? So it's having X coordinates, Y coordinates, and it's laid out perfectly, and yeah. That's how the game works. That's how the blocks are constructed and positioned, and how the cursor is also moving. So if we're moving here, this is called the cursor. It cannot move out of its boundaries. So yeah, it cannot move down. The only thing it can do is move around fast if you hold into a direction, or you can also swap blocks. So here you see that. If they're both real blocks, you can also swap a lot of times. And they animate. So this is all the cursor can really do. It's just moving around, swapping blocks, and yeah. It's pretty cool. But that's really what it does. Not more, not less. It has no more impact. So it's pretty easy. The only thing that is a bit difficult is, the boundaries here and making it call other blocks and such. So as well as that, you can see what blocks actually do. So if 3 of the same color match in any way possible, they dissipate, or they're just getting removed, right? Or you can make abstract patterns like this, which is an L form, and it'll go away. And that was a combo of 5. Normal combos are 3, so that's a 3. We also had a 6 combo here, and in general we have so many blocks cleared. So some info already. Yeah. So with that, all the states that we have right now for the block are idle, so it's doing nothing. The next state that we look for is in idle. We are looking for if the block is above air, so like that, it's gonna fall down. So that's pretty interesting, right? It's gonna fall down, and then it transitions to a false state. The false state, then just each frame it's gonna fall down. So it's pretty fast. You cannot really see it. It almost looks too smooth to be, true. But it's falling down frame by frame. So that's a false state, and it's gonna land somewhere. So it also has a land state. So once it falls down, it animates a little bit. Has that quirky animation. And that's land state pretty much. And also we have a move state, so these blocks can move around and animate, so it's a bit more smooth. It's not instantly. Another thing that we have is a clear state. So it's being cleared the whole time, and nothing can happen between that. So I cannot swap these blocks into there now, only after they've gone away. So that's all the block states that we have. So like I said, I didn't say it, but we have a finite state machine. It's important that we have that, so that we can define rules easier of how the blocks work and such. That's just really important. That was a big issue back then. So that's really it, though. I haven't come any further because this already took too much time. But yeah, let me explain a little bit of how the blocks are positioned and how you maybe can access them in code. So yeah, if we just take a look at this is how a grid looks right now. If we run it again, cargo run, you'll see there are 6 blocks on the bottom, and they go up 12 to the top. So 6 to the right, 12 to the top. By the way, Amethyst is constructed from the bottom left coordinate, so it starts here, where my mouse is pointing. Usually game frameworks start from the top left, so if you go with the Y up, you go down, and if you go Y minus, you go backwards. So it makes a bit more sense to go, when you go Y up, that you actually go up. So, better or worse, but usually the way how normal games work is with top left coordinates. So yeah, so 6, 12. So what you usually would do is maybe make a multi-dimensional array and store these things, but it's bad. It's a lot to work with, and most of the times you don't really need that. So, oh, little crack. What you can do is here, you can say, instead of having a multi-dimensional array, you can have an array that goes on and on. So it's 6 by 12, and you only need one variable, this I. So with that, you can say, okay, blocks go on, and then you can say, okay, each 6, you want to cut this up and move downwards. And the way this works is with a function here. So you have an iterator, this is the x value, this is the y value. So x goes from 0 to 5, and y goes from 0 to 12. So I can actually show you this. I have a stack. So here's the whole function. So this is the x coordinate. It just takes I modulo columns, which is 6. And then the y is a bit more complicated. It's just I through columns as f64. So we can floor this number, and then we return a U size. So since this is pretty heavy, you shouldn't do it so much, or you should just do it once and keep that value, or keep the x and y. So this is what I'm saying here. You shouldn't be used so often. But this is basically how the game works, and we don't need x and y all the time. That's the thing. We only need to give it to the block, to the whole grid once. So that's the thing with this game. The blocks don't really move. They stay in the same position all the time, and then the only thing that happens, for example, in the move, when we move this, is the left spot gets an offset, and that offset moves the whole time to the right, and once it hits that one spot, or in 5 frames it's gonna hit that spot, we just wanna go back to the old position, 0 the offset, and then we just want to swap the properties. So this is what you do most of the time in the game. It's just you're swapping properties because that's easier. Why would we make this component be a real thing, have physics or something, when we can just simulate it? Falling is pretty difficult, and it's not real physics falling. It looks pretty good, and it needs to be frame correct. This is what the old games do. We don't want physics which can collide, and oh my god, and shit, now it collided with this other block, and oh no. no, we want this to be exactly what we want, and to be testable, right? So test code, like I said, is really important, and everything in this game is frame based. So you can argue if that's good or bad, but it definitely helps with making the game work at different difficulty levels. So you can later on in the game you can just say, okay, the amount of frames the block stays up in the air, you can modify that, and it just falls a lot quicker. Or how long this clearing takes, you can make that a lot quicker. And you maybe saw that in the video, but it can get really fast, and the game gets really difficult. So that was a 3 chain, and it's pretty easy to do if the game runs really slow, or if the difficulty is really easy. But it gets really competitive and hard and such. So like I said, everything is a grid. So, and we only swap properties. So what happens here is we animate the movement with an offset, and then once everything is done, we go back to the old stuff and we just swap the properties. So for example, the red block is 0 and the yellow block is 1. We can just say, okay, after everything has finished animating and such, we're just gonna switch the numbers. So now this is gonna be 0, now this is gonna be 1, and that's exactly what happens. We animate and then they switch. Animate, swap. Now it's a bit more complicated, but yeah, this is how the game works, and it's the same with falling. We just swap properties the whole time. So when it falls down, it swaps the properties with the lower one, and it goes on and on until it hits the ground, and then where we are. And this is pretty easy to do. It requires a state machine as such. In ECS this is pretty difficult and maybe a bit messy, but it works, and it's pretty cool. And like I said, we can maybe even, and it's pretty safe to do. You just need to clone blocks and clone some data and swap the data. That's really important. But that's all we really need to do. So like I said, we're just swapping properties, and this is how the game works. And I'm probably at 20 minutes or so, 30 minutes, okay. I'm just going to quickly show you how the whole game is constructed right now, if you're interested, obviously. So, be aware of messy code. So, we have Amethyst, right? We need to start it up. And here is the whole logging system. I've made it to only warn us, so it doesn't log everything the whole time. It just logs. So it logs any warnings, or, oh, this doesn't work. Well, this is going wrong. So then we have an Approot, which is our path to the user. So we always need that if we want to access any files on the system of a different user. So without this, it might work on my system, but it maybe doesn't work on your system. And this prevents it, this root. So we get a display config, which is our display. So here, it gets all of the info here, and it runs the whole game with this. So the data is stored now, and now we can make a pipeline, which always has a white background and has a path. So it draws sprites with transparency. That's important for our cursor, since that has alpha values of 0. So then we have a random seed. So the game is based on randomization, right? So we always want a random seed, and this is a way we can do it with just getting random values. Here's also a seed that's always going to be the same. We could run the game with just that. For example, I could do that real fast and show you that it works. If I could find it. Oh my god, where's the seed? Okay, here. So if we do this, if I change the seed to some seed, and if we run the game again, recompile it, oh god, I almost pressed stop recording. Okay, so, damn it, I didn't save. Cargo run, okay. So here's the issue with Rust, it takes a bit of time to compile. I think that's okay for the safety we get in code. It tells me that something is wrong or right. So here's the thing. Now we're using a static seed, and every time we rerun the game, you'll see it starts out the same. So memorize this pattern. So we have a block that's blue on the top, and then a purple. Rerun the game, and it's the same. Pretty easy. But we don't want that. We don't want that for now. It's good to debug things, but yeah. So, we skipped a bit. So here we have all the configuration for the input. We put that into an input bundle. Why is that? Well, we need input in our systems. That's why. So that we can say, okay, if this button or if this action was pressed, tell me. Pretty much. So then we built the whole game. We build it with a bundle of transform so that we can move around entities. We build it with a render bundle, which takes our window properties. It has a sprite processor. We need that for sprite sheets. We have visibility sorting, which takes a transform. This is needed if we want to hide objects or make objects or entities, hidden. Bundle, that's the input bundle. And then we have our own systems, which I'll explain later. So systems are pretty much just the whole logic. So we have block logics, cursor logic, and then playfield logic, which deals on blocks. Okay. Sorry. Want to go fast. So we have assets as well. We need to define that for our game. We also have a display again. We run everything, and I limit the game to 60 FPS. Wow, and that's it. Quite a lot of stuff. So here is where we head next, our game mode. This will be different each time. We can have different game modes, single player, multiplayer. For now, it's just single player. But obviously, we'll add more game modes. But what we're doing here is we have the seed, we store it. We also have the config, so we can do things upon it. Then I'm creating a lot of blocks. Block entities 0 to 6 times 12 that I talked about. Or just, we're using this I, which is going to be x to y. So we take this function here as well to get the x, y. Then we also have a transform, which scales the whole game up. So it's not as small. Then we also put a sprite render component on this. We load all the sprite sheets, all the sprites to the sprite sheet. And then we push all entities onto a vector here. And that vector gets stored later so we can access it, for our purposes. And then we create the whole entity. So the block contains of a sprite render, the whole block data itself, then a global transform, and then a normal transform. We also initialize a camera. This is dependent on how big we've defined the config. So it's always going to be going until defined width and height. Alright, so the game mode, I switch to that. So we run everything, we create everything. Here I have my random number generator for the whole kinds. So you see in the game, if we run it again, you're gonna see that blocks never match, so once they're started, or all the random numbers pretty much, they're never going to be the same next to each other, so there will never be a green one next to this, there will never be a yellow one next to this, and such. So, my random number generator. So we can go into that. It's a bit more complex. If you like looking at this sort of stuff, go ahead. Tell me this isn't used. But pretty much we can make a whole stack, or we can define a width or some dimensions. We should create a 1x6 row of random numbers, something like that. So again, game mode. Wow, I'm talking a lot. So it's pretty complex. ECS is complex. Amethyst is a bit complex, but it's worth it, guys. I love ECS now, and I've worked with object orientation a lot, and I'm just, I love it. It's definitely harder, but once you unlearn the patterns of object orientation, it's really good. So here we manually create the cursor as well. And that's just the creation of the whole entities, and that's it. And then we initialize the camera. So now it's pretty much just, we've created everything, and now, the entities are there. What do we do? Well, first up, entities are components, right? So here's the block data, and it's pretty big, but it doesn't really have too much logic. So all these variables, I try to say what they do. So the kind, for example, says the sprite number. If kind is 0, it's gonna be red. If kind is 1, it's gonna be green. That sort of thing. If it's -1, it's invisible technically. But yeah, so then we have an ID that's unique to this block, or the spawned ID, for example. Then we have XY, which is its position. We have an offset. We have a move direction. We have a current state. We have a counter for the state machine. We have all these clear variables, animation variables. So we have a default. So now we can say in new. The only things I want to modify is the ID, kind, X and Y, and then the rest is going to be this default here. So then in this block component, I only have calls that are like returning bools or things like that, just getters, setters sort of thing. So set properties, reset, and then we have a implement component. So this is what all components need to do. So that was pretty complex. The cursor is really simple. It just has X, Y, animation, also an offset. We just set that in the default. Same thing here in the new. We have a set position. It handles on the transform. The transform has a translation. The translation has XY, so we set that to our XY. Then we say the size that blocks will be at. Then we have a scale of the whole cursor that we define in the beginning. Then we have an offset, which is optional. And yeah, that's pretty much it. Then we have another component, which is a stack. This pretty much holds block entities. And the stack is sort of used for getting entities or getting block entities. And it's just like, it has these helper methods pretty much. So I can say from I, which is just, accessing the array from I, or I can say from XY. So I don't need to call this the whole time, or, it's just easier. And also you can do printing and such a lot easier here. So yeah. Spreadsheet loading is pretty complex. You gotta look into that yourself. So the thing is, we have a state machine. So quickly, I just want to go over the systems. I know we're probably at 40 minutes. Wow, 45. Well, Jesus. Like I said, I just want to show you the game, how some of the code works. So we'll start with an example of the frames per second system. This just prints out frames per second. And this is all that a system really does. It goes through the whole system, or you pretty much just define the system. You define the components that you want to get. So in this case, you get a read, so you get just a reference to the time, so current time, and then you also get a write to the FPS counter. That's an Amethyst thing. So in this run function, which runs every frame, you get your reference of time. You can get data from it, so delta real time. You have your write variable or your write resource, the FPS counter, which you can push new things on. So in this case, you just push new time on it, and then here we just print out the current FPS and sampled FPS. So that's how it works. That's how a system works. It gets the components, it reads them, and you can do things upon it. Well, now it gets a bit more complicated. Let's go to the cursor now. So I won't talk about this. I have some key pressing. Amethyst has key pressing, but not based on actions, and actions are the sort of thing that can be key presses or controller buttons. So if you press a button A on your Xbox controller or whatever, that you get that action as well. So that's what I simulate here, and I also count the frames on how long an action might take. So if I press the X key 10 frames, then stuff will maybe happen differently. So I have that for the moving, so that it's, if you hold the button down for a longer amount of time, that you get some return true stuff. Alright, pretty complex. So here it gets a bit more complex. So the cursor has a sprite, so we need a sprite render. So now we can modify or animate the sprite render. We can say, okay, it should go in its sprite sheet, it should go one to the right, and then further and further, depending on how we animate it. Then we have the transform that we can modify with the write storage. We can say, okay, transform X now goes further or left or whatever we want to say. We have a write storage cursor, so that we can modify the data that we have defined in the cursor component. We have the input handler. That's the input bundle in the beginning. We have our random number generator that's unique. That's making unique random numbers. And then we have a write storage, which allows us to modify blocks, a block component, so everything you saw in the block file. Then we have a read storage for the stack. The stack should never change. That's why we have it on read. Then we have this run function. Here we have like some complex, if it's held down, go on every cursor and then see if the cursor is still in the boundary, and that happens quite a few times. And then we have also press detect, because for some reason there's no pressing an action, so I had to do it myself. When you press space, it regenerates the whole number, so each block gets a new kind. Then if we press swap, some swapping happens. Here we set the cursor transform. Here we set the sprite number based on animation. And yeah, maybe you've recognized a pattern. You get all the write storages and such. You combine them like this in a for each. So for sprite, which equals immutable sprites, for transform, immutable transforms, and for cursor, immutable cursors. So now you can modify each of these mutable references. So I can set the transform now, I can set the sprite number, which is just really helpful, right? I can set cursor variables and such. With that said, more logic. So why don't we go over, wait, not sure if this is the right way to show this off, but it's complicated to do logic in Rust or Amethyst ECS because it's complex, right? You cannot have multiple mutable references. That's the issue. So you cannot have something like mutable here, and you cannot have mutable here. It will just not work. And it's going to show you in a second. Mutable borrow happens 2 times. Yeah, so here. Yeah, so you can get it. You can get multiple references, but you cannot get multiple mutable references. So that's why we need to, for example, here I have a can swap. That's a Boolean value that's false right now. And then I get some references, and then some more references later on, and then I'm just comparing. Okay, comparison can happen between references, no problem. And then I return, okay, current swap is true. Wow, such a big pile of code, right? So now I can do, and if that was true, I can actually do some logic, and here it gets a bit more complicated. It has a lot of get mutable, and you need to look out, okay, where's the mutable at? Is it in this lifetime? And sometimes you need to do this, specify a lifetime. So in this colon, it's gonna stay here, you won't use it otherwise because you cannot. It's because of this lifetime. And then the same thing for the other mutable reference. And yeah, that's pretty much how it works. And then it's more logic based on that. And this is how you modify blocks between each other, by the way. So in this case, we create whole new blocks that are empty, so default. Then we can say, okay, we want to clone both. So we take a reference, we unwrap it, and then we clone it to this block. Same for the right one. And then later on, we'll just say, okay, this mutable block now should take this block from the other one. So the one I plus 1, so this one, the right block, should now take the left block. So the left block now should take the right block data. It's complex. But that's pretty much the gist of it. Hope you understand it. And that's basically how ECS works and how programming system works and all this sort of jazz. And it gets more and more complicated. And for example, here, that's why a finite state machine is really helpful for this. Wow. So here it gets a bit more complicated because I hide objects. You gotta learn Amethyst, and if you have any other questions, ask me, write me on Discord. And yeah, but pretty much here I have a lot of states. Execute happens each frame. Counter end happens when its counter is at 0. And the counter is counting down. So then we have a generic trait here. Not a generic, but just a trait. So here I define them. Execute happens each frame, like I said. Enter happens once if loaded into another state. Exit happens when leaving to another state. So all these calls that you can just define in a state and then say, okay, this should happen if it leaves. And then this is how changing a state happens. It looks whether the state, so it matches for the state, it calls the exit. Then it says the block state is a new state, and then we call it enter. So a really easy example is hang. All hang does is it makes, in the enter, it sets the counter to 10, and then until it counts down, all we do is we change the state to fall, and then fall gets hit, and it's a bit more complicated since we need to swap properties again. But idle, for example, as well, it's just execute. Okay, can we hang? Is there a block below that's invisible? If that is true, get the mutable, get the mutable, set it to hang. Otherwise, do something else. It's pretty simple, easy. That's why I try to do. Sometimes it cannot be as simple. But here's a swapping animation, for example. It just takes a bit of getting used to, right? And then clearing. Most of the states just handle animation, like this here. It's just animation. And then some logic here as well. But yeah, I hope you liked it. It gets a bit more complicated. Now I'll extend the playfield. The playfield handles all data over, the whole blocks. So not just a single block, but it gathers all blocks and sort of deals upon them, and it stores data inside them, like how many combos do we have, what's the highest chain, and how many blocks have been cleared, that sort of thing. So I've just been getting started here. And yeah, this is where the project is at right now. I hope you liked it. 65 minutes. I hope this was enough. If you still have a lot of questions, add me on Discord. Write me there. If a lot of people will come, I'll make a new channel so we can all write together. Like I said, I really want this to be... I want this to evolve. I want this project to go right. And, we can also have new sprites and such. Obviously, Nintendo has a license to that. If they tell me to take it down, I'm just going to switch the sprites. And yeah, look through the code. Tell me what's wrong. Build it yourself. If you're on Linux, for example, you can build the game and then make a pull request, and I'll add it to the releases, so other people who don't know about programming can just simply download the Linux version and run it on their PC. That sort of thing. So hope you liked it. I'm just gonna end the video now. It's way too long, but I hope I went clear enough on this, and this is really where the project is at right now. It, has a state machine, blocks have logic now, and all this other jazz. It's working, it's good, and I love it. So that's about it. Thanks for watching. See you next time.